air, water, and weather. Time to warm up. Can you write a good caption for the picture? Time to know. The atmosphere. Earth is the only planet in the solar system with an atmosphere that can sustain life. The blanket of gases not only contains the air that we breathe but also protects us from the blasts of heat and radiation emanating from the sun. It warms the planet by day and cools it at night. Earth's atmosphere is about 300 miles, 480 kilometers, thick, but most of it is within 10 miles, 16 kilometers, the surface. Air pressure decreases with altitude. At sea level, air pressure is about 14.7 pounds per square inch, 1 kilogram per square centimeter. At 10,000 feet, 3 kilometers, the air pressure is 10 pounds per square inch, 0.7 kg per square centimeter. There is also less oxygen to breathe. The gases in Earth's atmosphere include nitrogen, 78%, oxygen, 21%, argon, 0.93%, carbon dioxide, 0.038%. Water vapor and other gases exist in small amounts as well. What is in the atmosphere? The Earth's atmosphere is divided up into 5 major layers. Exosphere. The last layer is the thinnest. It goes all the way to 10,000 kilometers above the Earth's surface. Thermosphere. The thermosphere is next and the air is very thin here. Temperatures can get extremely hot in the thermosphere. Mesosphere. The mesosphere covers the next 50 miles beyond the stratosphere. This is where most meteoroids burn up upon entry. The coldest place on Earth is at the top of the mesosphere. Stratosphere. The stratosphere extends for the next 32 miles after the troposphere. Unlike the troposphere, the stratosphere gets its heat by the ozone layer absorbing radiation from the sun. As a result, it gets warmer the further away you get from the Earth. Troposphere. The troposphere is the layer next to the ground or surface of the Earth. It covers around 30,000 to 50,000 feet high. This is where we live and even where planes fly. Around 80% of the mass of the atmosphere is in the troposphere. The troposphere is heated by the surface of the Earth. The atmosphere protects life. The atmosphere provides oxygen for breathing to all living things. It provides carbon dioxide to plants for making food for living things. The atmosphere absorbs a large part of the heat of the sun and prevents the Earth from getting overheated. At night, it retains heat and prevents the Earth from freezing cold. Near its top, the stratosphere contains a layer of a gas called ozone. The sun gives out rays known as ultraviolet rays. These rays are very harmful to living things. They cause skin cancer and problems in the eyes. The ozone layer absorbs most of these harmful rays and protects us. Properties of air. Shall we learn about the properties of air by doing a few experiments? Experiment 1. Materials needed: 2 balloons, 12 inches long stick, thread and a pin. Procedure: tie a piece of thread in the middle of the stick. Tie 2 balloons filled with air at both ends of the stick as shown in the figure. Hold the stick with the help of a thread like a balance. What do you observe? Prick one of the balloons with a pin. What do you observe now? Serial number, experiment stage, observation. Balloons are balanced, the stick is straight. The end of the stick with filled balloon goes down while the end with the deflated balloon rises up. Reason: both balloons have equal quantity of air. Balloon filled with air is heavier than the deflated balloon. Conclusion: this experiment shows that air has weight. Experiment 2. Materials needed: a glass tumbler, a square piece of cardboard as shown in the figure, and water. Procedure: take the glass tumbler and fill it with water up to the brim. Hold it with your left hand. Close the mouth of the tumbler with a cardboard and press it with your right hand. Holding the cardboard firmly with your right hand, invert the tumbler. Now carefully remove your right hand. Experiment, observation. Reason: the cardboard does not fall even if the right hand is removed from it due to the pressure of air. Conclusion: this experiment shows that air exerts pressure. Experiment 3. Materials needed: empty jar, a lightweight ball, and pieces of paper, a glass tub filled with water. Procedure: keep a lightweight ball floating on the surface of water in the glass tub. Fix pieces of paper inside the jar at the bottom. Hold the mouth of the jar over the floating ball and press it down till the mouth touches the base of the tub. Observations: water did not enter into the jar. The pieces of paper fixed inside the jar at the bottom did not get wet. The ball which was floating is now at the bottom. Reason: the air present in the jar did not allow the water to enter into the jar. Conclusion: this experiment shows that air occupies space. The pieces of paper fixed inside the jar at the bottom did not get wet. Do and observe. Keep a lighted incense stick at the corner of your house. What do you observe after a few minutes? The smell of incense fills the entire house. Air spreads in all directions. Uses of gases present in air. We know that air is a mixture of nitrogen, oxygen, carbon dioxide, and gases like neon, argon, krypton, and xenon. Oxygen is essential for the survival of all living organisms. When we breathe, we inhale oxygen and exhale carbon dioxide. People who climb mountains, those who dive into the deep sea, and the researchers going to space all carry cylinders filled with oxygen in order to breathe. Carbon dioxide is used during photosynthesis in plants. It is used in aerated drinks. Solid carbon dioxide, dry ice, is used as a freezing agent. Nitrogen is used as a natural manure. Inert gases: neon, argon, krypton, xenon are filled in bulbs which give bright colored lights. Windmills. Windmills use wind to generate electricity. Large number of windmills have been erected in places like Aralvaimuri and Kayyathar for generation of electricity. Air spreads in all directions. Applications of air pressure in our daily life. To ill medicine in injection syringes. ill ink in pens, to suck cold drinks using a straw, to construct artificial fountains, to operate hand pumps, for the working of sailboats, parachutes, and kites. Water. Life, both animal and plant, is impossible without water. Without water, men die of dehydration. About 70% of the human body is water. Of the total surface of the earth, 75% is water, and just below the surface of the land in most areas, there is a saturated layer known as the water table. Animals and plants have large percentages of water in their makeup, and some animals regulate their movements according to the water sources. If there is no water, there can be no life. The moon is a sterile desert because there is no water in it. It is to be remembered that it was water that determined the location of human settlement, and without the Nile, the Egyptian civilization would not have developed. The Nile provided the Egyptians facilities for irrigation and transportation. As Herodotus said, Egypt is the gift of the Nile. Water dissolves in many things. Put some salt in a bowl of water. Stir the water with a spoon. The salt disappears. Now taste this water. How does it taste? It tastes salty. Why? Where did the salt you mixed go? The salt you mixed in the bowl of water did not disappear, but dissolved in water. That is why the water became salty. The salt and water together form a salt solution. The water here is called the solvent. Salt, the substance that dissolved in water, is called a solute. Thus, we understand that water dissolves many substances. These substances are said to be soluble in water. The ones that do not dissolve in water are insoluble in water. Impurities in water. Water is a universal solvent, and in nature it is never totally pure. No matter how isolated it is from sources of contamination, it will always have some chemicals. Gases or minerals in the air, soil, or rock are dissolved by the water. Some dissolved materials give water its characteristic taste, and pure water is generally considered to be flat and tasteless. Minerals can cause hardness, calcium or magnesium, color, iron, contamination, arsenic, and radioactivity, radium radon in the water. Humans can use contamination through the improper use of pesticides or fertilizers and through the disposal of waste. These impurities can dissolve in the water, causing it to be contaminated. Minerals and impurities are normally present in very small concentrations and are measured in parts per million, ppm. How many parts of impurities in a million parts of water, or milligrams per liter, mg by L? The terms are equivalent and are used interchangeably in water and wastewater. Removing insoluble impurities, sediment. Take a glass of water. Put some mud in it and stir. Does the water become muddy? Now, let's keep the glass undisturbed for 10 minutes. We will find that the insoluble mud particles settle down at the bottom of the glass, leaving clear water on the top. The mud that settles down is known as sediment. Now carefully pour out the clear water into another glass. The sediment is left behind. The process is known as decantation. Filtration. Procedure. Pour your swamp water into the 2-liter bottle with a cap. Have students describe the appearance and smell of the water. Aeration is the first step in the treatment process. Adds air to water. It allows gases trapped in the water to escape and adds oxygen to the water. Place the cap on the bottle and vigorously shake the bottle for 30 seconds. Continue the aeration process by pouring the water into another bottle or the beaker, then pouring the water back and forth between them about 10 times. Once aerated, gases have escaped, bubbles should be gone. Pour your aerated water into your bottle with its top cut off. Coagulation is a process by which dirt and other suspended solid particles to chemically stick together into clumps of alum and sediment, so they can easily be removed from water. Add 2 tablespoons of alum to the aerated water. Slowly stir the mixture for 5 minutes. You will see particles in water clinging together to make larger clumps. This makes it harder for them to get through a liter. Attach the coffee filter to the outside neck of the bottle with a rubber band. Turn the bottle upside down, placing it in a beaker or cut-off bottom of a 2-liter bottle. Pour a layer of pebbles into the bottle. The filter will prevent the pebbles from falling out of the neck. Pour the coarse sand on top of the pebbles. Pour the fine sand on top of the coarse sand. Clean the filter by slowly and carefully pouring through 3 liter or more of clean tap water. Try not to disturb the top layer of sand as you pour the water. Filtration through a sand and pebble filter removes most of the impurities remaining in water after coagulation and sedimentation have taken place. After a large amount of sediment have settled on the bottom of the bottle of swamp water, carefully, without disturbing the sediment, pour the top 2/3 of the swamp water through the filter. Collect the filtered water in the beaker. Pour the remaining 1/3 bottle of swamp water back into the collection container. Compare the treated and untreated water. Ask students whether treatment has changed the appearance and smell of the water. Advise students that the final step at the treatment plant is to add disinfectants to the water to purify it and kill any organisms that may be harmful. Because the disinfectants are caustic and must be handled carefully, it is not presented in this experiment. The water that was just filtered is therefore unit to drink and can cause adverse effects. It is not safe to drink. Removing soluble impurities. Objective: make fresh water from salt water by using the process of distillation. Materials: table salt, tap water, thermometer, 250 ml beaker, Bunsen burner or electric burner, 2 stands, camera, tablespoon, basin, Liebig condenser, rubber tubing, tripod, paper towels for cleanup, sand, distilling husk, stand, rubber stopper, 2 clamps. Experimental procedure: Gather all the materials you will need for this science project. You may wish to include a camera and take photos to include in your report and use on your display charts. Put on your safety equipment. Set up the distillation apparatus and shown in the diagram below. Start by filling your beaker with tap water and add 1 tablespoon of salt. Mix well. Pour the salt water into the distilling flask. Place sand in the basin and now place the distilling flask into the sand before you start heating it. Carefully place the burner under the flask. Connect the distilling flask to one end of the Liebig condenser. Place the condenser so that it slopes downwards and that its other end is directly above the beaker. Bring the salt solution to a boil. Keep an eye on the thermometer. Collect the water vapor that is now turning into liquid water. Observe. You will find the water is tasteless and has no distinct odor. Heat source. Thermometer, boiling point temperature. Condenser, cooling water out. Vacuum, gas inlet. Heat control. Stirrer, heat plate. Stirrer bar, anti-bumping granules. Cooling bath. Still pot. Cooling water. Cooling water in. Distillate receiving flask. Still receiver. Stirrer speed control. Heating, oil, sand bath. Still head. Drinking water. Boiling water. Place the water you wish to purify in a bowl. Place the bowl on the stove and turn the stove on to high. When water boils, any bacteria that may have been living in it will be killed, thus reducing your chance of getting sick when you drink the water. If you are in the wilderness, when you need to purify your water, build a fire to boil your pot on. If you do not have pot, you can use any container that is fireproof. Bring the water to a rolling boiling. When bubbles begin to appear, it means that the water is starting to boil, but continue heating until the water goes into a hard rolling boil. Then start timing. Continue to boil the water for 5 to 10 minutes plus 1 minute for every 300 meters above sea level, up to around 5,500 meters where boiling becomes ineffective. To have the most effect upon any bacteria and other microorganisms. Boiling water for 1 to 3 minutes will purify it sufficiently. It will kill off the vast majority of organisms living in the water. It also removes some chemicals by vaporizing them. However, be aware that boiling the water will not remove solids, metals, or minerals. Also beware that the boiling point of water decreases with altitude. So you will not get the same purification effect on a mountain top as you would on a coastal plain. You can boil the water longer or use a pressure cooker to offset the lower temperature. Remove the pot from the heat. Use caution when handling the pot and water as they are, as you may have guessed, very hot. Let the water sit and settle. You do not need to do this if you are boiling water that came from a tap and you feel sure that there are no solid items, minerals, or metals in the water. If you let the water settle, any dense items in the water will sink to the bottom naturally, allowing you to drink the pure water from the top.